Hello again, this is Anand Kumar and welcome to my video lecture series number 3. In this video lecture series number 3, we'll just start with the last class's continuation, that is nothing but producer-consumer problem. So, producer-consumer problem is a classical synchronization problem in the operating system. With the presence of more than one process and limited resources in the system, the synchronization problem arises. If one resource is shared between more than one process or processes at the same time, then it can lead to data inconsistency. In the producer-consumer problem, the producer produces an item and the consumer consumes that item and that is produced by the producer. So what is actually the producer-consumer problem? Before knowing what is producer-consumer problem, we have to know what are producer and what are consumers. In operating system, producer is a process which is able to produce data or item. Consumer is a process that is able to consume the data or item that is produced by the producer. Both the producer and consumer share a common memory buffer. This buffer is a space of certain size in the memory of the system which is used for storage. The producer produces the data into the buffer and the consumer consumes the data from the buffer. So this is the diagram for your reference, that is the consumer, like the producer produces and stores its item, the data, in a buffer, and the customer, that is consumer, gets the data from the browser, that's the buffer, and that has been produced by the producer. So what are the producer and consumer problems? Process shouldn't produce any data when the shared buffer is full. So the producer-consumer problem, what are the producer-consumer problem? The producer produces or the producer process shouldn't produce any data when the shared buffer is full. Consumer process shouldn't consume any data when the shared buffer is empty. The access to this shared buffer should be mutually exclusive, that is, at a time only one process should be able to access the shared buffer and make changes to it. For next, or the consistent data synchronization between producer and consumer, the above problem shouldn't be or should be resolved. The next is solution for producer consumer problem. So to solve the producer consumer problem, there are three semaphore variables involved or being used. Semaphores are variables that are used to indicate the number of resources available in the system at a particular time. Semaphore variables are used to achieve process synchronization. So these are the semaphores that has been used for process synchronization, that is full, empty, and of course mutex, that is mutually exclusive. The full variable is used to drag the space filled in the buffer by the producer process. It is initialized to 0 initially, and initially no space is filled by the producer process. The next is empty. The empty variable is used to drag the empty space in the buffer. The empty variable is initialized to the buffer size as initially the whole buffer is being empty. Mutex is used to achieve mutual exclusion. The mutual exclusion, like mutex, ensures that any particular time at any particular time only the producer or the consumer is accessing the buffer. The next is mutex is a binary semaphore variable that has value of 0 or 1. We will use the signal and wait commands operation in the above mentioned semaphores to arrive to a solution or to arrive at a solution to the producer consumer problem. In the signal function increases semaphore value by 1, that is wait. The wait operation decreases the semaphore value by 1. Let's look at the code for the producer consumer process. The code for producer consumer is as follows, that is the producer, while being the condition is true, it waits for mutual exclusion, and if it is successful, it adds and mutex value, that is signal, to be full, that is incremented by 1 value. Let's understand the above producer consumer code, that is wait empty before producing the item, that is the data or the items. The producer process checks for the empty space in the buffer. If the buffer is full, producer process waits for the consumer process to consume items for the buffer. So the producer process executes wait empty before producing any item. So coming to the wait, that is mutual exclusion, only one process can access the buffer at a time. So once the producer process enters into the critical section of the code, it decreases the value of mutex by executing wait, that is in this case mutually exclusive, that is or mutual exclusion the terms, so that no other process can access the buffer at the same time. So there are many other processes like add, signal in terms of mutual exclusion, and then next. So the remaining we'll see it in the next class. Thank you.